Hi students, I'm your Nagini ma'am chemistry mentor. In today's session, I'm giving 4 excellent tricks to find the highest bond angle. Okay na? So this is the topic from 11th class chemistry, chemical bonding. So trick number 1, see students, trick number 1. So what is the trick number 1? Bond angle. Bond angle is directly proportional to the bond order. It is directly proportional to the bond order. Clear? That means bond order increases, bond angle also increases students. See here, bond order. For example, bond order equals to 1 means the nature of the bond is single bond. Next, bond order equals to 2. That means double bond. The nature of the bond is double bond. So, bond order equals to 3. 3 means the nature of the bond is triple bond. Clear? So take here 3 examples. See, this is the single bond, this is double bond, this is triple bond. That means bond order equals to 1. Here bond order is 2. That means in between the two carbon atoms, single bond is there. Bond order, this bond order is how much? Bond order 1. Means the nature of the bond is single bond. Bond order is 2. Means the nature of the bond is between the two carbon atoms, the nature of the bond is double bond. Here triple bond. The bond order is 3. So bond order equals to 3. The nature of the double bond is nature of the bond between the two carbon atoms, triple bond 3. Understanding? So here bond angles, if you observe how much it will be there. So here bond angle between the orbitals, this is 109 degrees. Here double bond, here bond angle is 120 degrees. This bond angle 180 degrees. Understanding? So bond angle 180, 109, 120, 180. That means bond order increases, bond angle also increases. Understanding? Bond order, single bond, double bond, triple bond. Bond order to bond order increasing, bond angle also increases. Understanding? So here bond order, bond angle increases. So what is the symbol students here? Increases, less than. Clear? Understood, Amma? So bond order increases, bond angle also increases. This is the trick number 1. Next, trick number 2. So what is the trick number 2? See here. Trick number 2. So what is the trick? See here, trick number 2. During hybridization, during hybridization, hybridization, bonded atoms, bonded atoms, bonded atoms, same. Okay, bonded atoms same, central atom and the lone pair, central atom, lone pairs, these two are different. This is the first case. Understanding? Bonded atoms same. Understood, Amma? So this is the very important trick. This you have to remember. Clear, students? Bonded atoms same, central atom, lone pairs different. Different. So then what is the trick here you have to follow? Bond angle during hybridization. Okay, bond angle, it is inversely proportional to the number of lone pair of electrons. Understanding? So number of lone lone pairs of electrons. So number of lone pairs of electrons. So bond angle is inversely proportional to the number of lone pairs of electrons. Inversely proportional. Lone pair of electrons increases, bond angle decreases, students. So bonded atoms same, central atom, lone pairs are different. What is this? Bonded atoms same. Take here one example, students. Take here one example. Bonded atoms same. Central atom lone pairs are different. For example, CH4, ammonia, water. Take here this example. Once you observe, Nana, which is having the more bond angle. That means here 4 hydrogens, bonded atoms these are. here hydrogen, here bonded atoms hydrogen, here hydrogen, here hydrogen. Carbon central atom, nitrogen central atom, oxygen central atom. Hydrogen, here hydrogen, 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 all are same bonded atoms. Clear? This is bonded atom, this is a central atom. So bonded atoms hydrogen, here hydrogen, bonded atoms same. Central atom lone pairs different. Central atom different. Carbon, nitrogen, oxygen, different atoms are there. Lone pairs, see here how many lone pairs around nitrogen? Here one lone pair will be there, correct? How many lone pairs? One lone pair. Here around oxygen, how many lone pairs? Two lone pairs will be there. Clear? Two lone pairs. That means lone pairs different. It is not having lone pair. Here no lone pairs. Understanding? Here one lone pair. Here two lone pairs. Understanding? Zero lone pairs. Here one lone pair. Here two lone pairs. Clear, students? Then what I told you, trick number 2, bond angle is inversely proportional to the number of lone pair of electrons. So number of lone pairs increases, then what happened? Bond angle decreases, students. Bond angle decreases. So here two lone pairs are there. That means lone pair of electrons more. That's a bond angle is less. Clear, students? So what is the order? So which is having the more bond angle? This one, methane. Because it is not having the lone pair of electrons, so it is having the more bond angle. So that's why here bond angle order, methane is greater than NH3 is greater than H2O. Clear, students? This is the trick number 2. Okay, during hybridization, bonded atoms same, central atom lone pairs are different. Central atom carbon, nitrogen, oxygen, all are different atoms. Lone pairs also different. Here one lone pair, here two lone pairs, here no lone pairs, zero lone pair. Clear? This is the trick number 2. Now we are taking trick number 3. During hybridization, trick number 3. So what is the trick number 3? During hybridization, bonded atoms different. So what I am saying here, bonded atoms different. Okay, bonded atoms different. Now central atom lone pairs, lone pairs same. Understanding? This is the main you have to remember, students. Understanding? So bonded atoms different, central atom lone pairs same. Understanding? So this table you have to remember. So bonded atoms different to central atom lone pairs same, central atom lone pairs same. So what is the example we can take? Here F2O, Cl2O, Br2O. See these compounds, 3 molecules are there. Bonded atoms different. Yes, these are the bonded atoms, fluorine, chlorine, bromine. These are bonded atoms. What is the central atom? Oxygen. Central atom same. Lone pairs also same. How many lone pairs here? 2 lone pairs. Correct? How many lone pairs? 2 lone pairs. Because oxygen valence electrons, 6 valence electrons. Here in 6, 2 only involved in the bonding with the 2 fluorines. Remaining 4 electrons, 2 lone pairs. So here also 2 lone pairs are there. Correct? Which are not involving in the bonding, those are lone pairs. Here also 2 lone pairs are there. Clear? So lone pairs same, 2 lone pairs, here also 2 lone pairs. Central atom also same. Yes, oxygen central atom, here also oxygen, central atom is same. Which is the different? Bonded atoms different. Fluorine here chlorine, here bromine. These are bonded atoms. Are you following? This is bonded atom. Clear? Bonded atoms. Then what is the trick here? What you have to remember? Bond angle is inversely proportional to the electronegativity of the bonded atoms. This you have to remember. So that means electronegativity of bonded atoms increases, then bond angle decreases, students. See here, fluorine, chlorine, bromine. These are bonded atoms. Electronegativity of bonded atoms which is in bonded atoms, which is having more electronegativity? Fluorine. Next to chlorine, next to bromine. So more electronegativity there means bond angle is less. Are you following? So that's why what is the order? F2O bond order, bond angle is less than Cl2O and it is less than Br2O. Clear, students? Clear. So F2O bond angle is less because bond angle is inversely proportional to the electronegativity of bonded atoms. So bonded atom here electronegativity more electronegativity, then more electronegativity there means bond angle less. So that's F2O bond angle is less than Cl2O less than Br2O. Are you following? So what are the bond angles? If you observe the bond angle, students, F2O, it is 103 to 105 degrees, Nana. Cl2O bond angle 109 to 111 degrees. This is 113 to 113 to 115 degrees. Clear, students? So these are the bond angles. So 103 to 105 degrees, 103 to 105 degrees. Next 109 to 111 degrees. Next 113 to 115 degrees. Clear, students? These are the bond angles. Okay. Right. So bond angles, what happen? Increases. Right. Next, last, trick number 4. So now listen, trick number 4. During hybridization, during hybridization, bonded atoms lone pairs, these two are same. Next, central atom is different. Now central atom is different. Clear? Central atom is different. So these boxes you have to practice, students. Okay, and next you have to follow the trick, this one. See here. So what is the trick number 4? So in this case, bonded atom same, lone pair same. Central atom is different now. Then then what is the bond angle order? See here, bond angle is directly proportional to the electronegativity of the central atom. Okay, now electronegativity of the central atom. So this one you have to remember. Understood, students? This you have to remember. Next, here this one is important. Clear? Clear? Understood. See here, bond angle is directly proportional to the electronegativity of the central. Bonded atom same, lone pair same. Central atom is different. Take example. So take one example, nitrogen, NH3, PH3, ASH3. So in these three molecules, which is having the more bond angle, maximum bond angle, which is showing. See here, bonded atoms same. Yes, bonded atoms, hydrogen, 3 hydrogens, bonded atoms. Here also hydrogen, here also hydrogen, same bonded atoms. Lone pairs also same. Nitrogen is having total 5 valence electrons. In 5, 3 only involved in the bonding with 3 hydrogens, remaining 2 electrons, 1 lone pair. So here 1 lone pair. Here phosphorus also having 1 lone pair. Arsenic also 1 lone pair. Because all are nitrogen, phosphorus, arsenic, these 3 are belongs to the same group, 15th group element or 50th group elements. Okay. So central atom is different. Yes, central atom nitrogen here phosphorus, here arsenic, central atom. These central atoms are different. Bonded atoms, so lone pairs, so same. Clear? In this case, what I told you, bond angle is directly proportional to the electronegativity of the central atom. So central atom electronegativity, nitrogen is having the more electronegativity. If I take nitrogen, phosphorus, arsenic, from top to bottom, what happens, students? Top to bottom, atomic size increases. Top to bottom atomic size increases. Then electronegativity, students, decreases. Electronegativity decreases. That means arsenic is having the less electronegativity, nitrogen is having the more electronegativity value. So nitrogen is having more electronegativity, means it is having the bond angle more. So order is NH3 is greater than PH3, bond angle is greater than arsenic hydride, ASH3. Understanding? So this is the trick number 4. Clear, students? Now one question, students, which of the following has the highest bond angle? Which of the following question which of the following has the highest bond angle? Option A, H2O, B, NH3, C, H2S, D, PH3. Phosphine. Okay, 4 options given. Phosphine. So in 4 options, which is showing the highest bond angle? So here you have to follow these 4 tricks, students. By using these 4 tricks, you can easily answer this question. Which of the following has the highest bond angle? See here, H2O, NH3, H2S, PH3. Here bonded atoms are same. Hydrogen, 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 hydrogen. Bonded atoms same. Central atom is different. Oxygen, nitrogen, sulfur, here phosphorus. Central atoms are different. So what is the trick number 2? What I told you. And here lone pairs also right here. Water, oxygen, around oxygen, how many lone pairs? 2 lone pairs now. Take here 2 lone pairs. Okay, around nitrogen 1 lone pair, sulfur also 2 lone pairs, because 6 valence electrons, 2 only involved in the bonding, remaining 4 2 lone pairs. Here phosphorus having how many lone pairs, students? Total 1 lone pair. Okay, 1 lone pair will be there. Now see here, what is the trick you have to follow? Bonded atoms same, hydrogen, 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 hydrogen. Number of lone pairs different, central atom is different. So then you have to follow the second trick. What is the trick number 2? I told you, students, trick number 2. Bonded atom same, central atom lone pairs different, means bond angle is inversely proportional to the number of lone pairs. So here number of lone pairs are more, bond angle is less. Number of lone pairs less, bond angle is more. Clear? Number of lone pairs, both are inversely proportional. So that means here only 1 lone pair. Okay, here also having 1 lone pair. So number of lone pairs less, bond angle is more. So that's why here lone pairs are more. So that's why option A is wrong, option C is wrong. You have to check only these 2 options, NH3, PH3. Number of lone pairs less. 1 lone pair, 1 lone pair. Now see here, bonded atoms same, hydrogen, hydrogen. Central atom different. Lone pairs also same. Here 1 lone pair, here also 1 lone pair. See here, trick number 4. What I told you, trick number 4. Bonded atoms same, lone pair same. Yes, here also bonded atoms, hydrogen, hydrogen same. Number of lone pairs also same. 1 lone pair, here also 1 lone pair. Are you following? 1 lone pair, 1 lone pair. Lone pair same. Bonded atoms same. Bonded atom, hydrogen, hydrogen same. Which is the different? Central atom is different. Clear? Central atom different. Nitrogen, here phosphorus. Then what is the trick I told you? Bond angle is directly proportional to the electronegativity of the central atom. So here nitrogen and phosphorus, which is showing more electronegativity? Nitrogen. So that's why more electronegativity there means bond angle is more. Clear, students? So which is the correct option? B is the correct answer. Clear? So B is the correct answer. Understood, students? Clear? So you have to follow these 4 tricks, Nana. 4 tricks. Very easy. Just to remember these boxes. What are the cases? Okay. Then you can easily answer this type of questions, students, from this topic. This is the topic from chemical bonding. So bond angle is directly proportional to the bond order. Trick number 1. Trick number 2. During hybridization, bonded atoms. Clear, the students? Any molecule is having single bond, that bond angle is less. So bond order increases, bond angle increases. During hybridization, bonded atoms same, central atom, lone pairs are different. This is the trick. Understood, students? So this trick you have to remember. Clear? Right. Here bond angle is directly proportional to the bond order. Clear? So this is the second trick. Next, trick number 3. During hybridization, this is the case, bonded atoms different, central atom lone pair same. So this is the example. Next, trick number 4, during hybridization, bonded atoms lone pair same, central atom different. This is the trick. Clear, students? I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, Lana. Thank you, students.